Hello friends, welcome to Vidya Pratishthan's guidance session for 8th standard scholarship examination. I am Mrs. Vidula Soman. I have done MSc Mathematics and B.Ed from Pune University. I have worked as a teacher in different schools in Pune. I have taught mathematics to students from 5th to 12th standard. I have also imparted guidance for 5th and 8th standard scholarship, CET and Homi Bhabha examination. I have worked as a coordinator in Dr. Tatya Saheb Natu Smruti Pratishthan's English Medium School, Margatamhane in Konkan. As a coordinator, I have imparted training to teachers right from nursery to 10th standard, and I have taught all the subjects right from nursery to 10th standard to all the teachers, different teachers. So, I am going to teach you mathematics from part 1 of your scholarship examination. As you know, your scholarship paper, you will have two papers, part 1 and part 2. Part 1 consists of language, which is your first language, and obviously that is going to be English, and the second section in that paper will be mathematics. English has weightage of 50 marks. Therefore, there will be 25 questions. Mathematics has 100 marks. So, obviously, there are 50 questions. We are going to learn different tricks, different ways how to arrive at the answer quickly and how to get the correct answer confidently by different methods. We are going to score the good marks by the proper guidance that will be imparted to you by all the teachers from the academy. We have to remember that there will be 20% questions will have two correct options, and we have to choose both the options. It is obligatory. Even if you choose only single option and you give that is correct answer, but you forget to give the second option, then your answer will not be considered as a correct one and you will get a big 0 for that. So, we won't make it happen. So, with proper understanding, proper conceptual foundation, we are going to deal with the course in mathematics. Teaching was never considered as a profession. I have always considered teaching as my passion, and so I am going to follow that while teaching you the mathematics for your scholarship examination. So, let us begin with the first chapter, and that is number work. The number work consists of working with the numbers. Which numbers? Natural numbers, whole numbers, integers and rational numbers. Of course, after rational numbers, we have different types of numbers. Those also we are going to learn, but that will be dealt with afterwards. So, let us begin with the natural numbers. You all are familiar with the numbers 1, 2, 3, 4, 5, 6, 7, 8 and so on. What are they? These numbers 1, 2, 3, 4, 5 and so on. These numbers we know are used for counting the objects, and that we have learned right from our childhood. So, we are familiar with the numbers 1, 2, 3, 4 and so on, and they are called as counting numbers, and also they will be called as natural numbers. So, group of counting numbers will be called as natural numbers. have to remember now the name natural numbers. Okay. So 1, 2, 3, 4, 5 and so on, they are all called as natural numbers. So 1 is the smallest natural number. After 1 comes 2. So 2 is greater than 1. 4 is greater than 3 is greater than 2. 4 is greater than 3 and so on and so forth. So does the counting come to an end? It never comes to an end. And therefore, the set of natural numbers is unending. It has infinite number of numbers or elements. Okay. So, the group of natural numbers, let us add 0 to the group of natural numbers. So, if I start with 0 and write 0, 1, 2, 3, 4 and so on, how many numbers are to be written? Few you can write. You may write 5 numbers, you may write 4 numbers, you may write 7 numbers, but don't write too many. Make a small list of the numbers one after the other and then put 3 dots. The 3 dots with a comma in between will mean that the writing or the counting or the group doesn't come to an end. So we have the numbers 0, 1, 2, 3, 4 and so on. They are called as whole numbers. So remember whole numbers. So which is the smallest whole number? 0 is the smallest whole number. Which is the smallest natural number? 1 is the smallest natural number. And which is the biggest natural number? We cannot find it out. There does not exist a number which will be considered as the biggest natural number. Which is the biggest whole number? Same thing. The writing or the counting or the number list of numbers doesn't come to an end, and therefore it is again, it has no largest number or the biggest number. Now we have written the numbers to the right of 0 as 1, 2, 3, 4. So 0, 1, 2, 3, 4 and so on will be the set of whole numbers or the group of whole numbers. If I write numbers to the left of 0, then obviously they will be different from these numbers 1, 2, 3, 4. And how they are different? They are different in their sign only. And we have all negative numbers to the right of 0. So to the right of 0 I will write -1. To the left of that is -2, -3 and again 3 dots. So this also list of negative numbers doesn't come to an end. So it is -3, -2, -1. Then I am going to write 0 and all the positive numbers 1, 2, 3, 4 and so on. So now see, the collection of numbers goes on increasing. Initially we started with number 1, we called them as natural numbers. Then we have started with 0, whole numbers. Now we have started with -infinity to -1, all negative numbers, and then 0 and then 1, 2, 3, 4 and so on. The group of all negative numbers to the left of 0 and positive numbers to the right of 0, and the number 0 itself, of course, that will be included. So this group of all the numbers from -infinity to +infinity, to the left are negative, to the right are positive. So 0 will be considered as the starting point. So to the left of 0 are negative, to the right of 0 are positive. So all the numbers from -infinity to +infinity, they will be called as integers. So integers. So which is the smallest negative integer? Obviously the numbers to the left goes to unending, that is to -infinity, and the number to the left is always smaller to a given number. So there is no number which is the smallest one, and therefore there is no smallest negative integer. But note that -1 is the biggest or the greatest negative integer. This you have to remember. So to the left of 0 are negative, to the right of 0 are positive. Minus 1 is these are negative integers. These are positive integers. Minus 1 is the greatest or the biggest negative integer. This is the greatest negative integer. What about positive integers? Which is the biggest positive integer? Obviously, there does not exist any number which is the greatest or the biggest positive integer, because the least does not come to an end. Least of positive integers doesn't come to an end. The least of negative integers doesn't come to an end. The negative numbers to the left go on becoming smaller and smaller, and therefore we do not have any smallest negative integer. Similarly, we do not have any greatest positive integer. Remember that. Don't get confused. Let us see which is the smallest positive integer. So, number 1 is the smallest positive integer. All the numbers to the right of 0, they are greater than 1. So, this is the smallest positive integer. So, 1 is the smallest positive integer. Please remember all these things. So, the question arises, we have described about minus 1, we have described 1. What about 0? 0 is considered as a signless integer. It is neither positive nor negative. So, it is signless integer. So, let us quickly revise. We have learned counting numbers 1, 2, 3, 4 and so on, which are also called as natural numbers. So, natural numbers start with 1 and the least does not come to an end. So, we have infinite number of natural numbers. Then we have whole numbers starting from 0, 1, 2, 3, 4 onwards. So, 0 is the smallest whole number, 1 is the smallest natural number. Then we have learnt integers. We have negative numbers to the left of 0, to the right of 0 are positive numbers. The number 0 also is considered, and the group or the collection of all the negative numbers and all the positive numbers, that is from minus infinity to plus infinity. All the numbers, they form the group of numbers called as integers. So, the group of integers consists of negative integers, positive integers, number 0 which is a signless integer. From the list of negative integers and positive integers, we can make out that minus 1 is the greatest negative integer, 1 is the smallest positive integer, there is no greatest positive integer, and there is no smallest negative integer. That you have to remember, right? You know that these numbers or the integers, they can be represented on a number line, that you have learnt. So, on a number line, if we represent the negative integers, positive integers and 0 obviously, which is a signless integer, what about the points that are between 0 and 1? So, because on a number line, every point is associated with some number. We have only represented the numbers 0, 1, 2, 3, 4 and minus 1, minus 2, minus 3 and so on the number line. What about the points between the numbers 0 and 1, represented by the numbers 0 and 1, or the other numbers. And so for that the answer is yes, we have the numbers which are called as rational numbers. So what are the rational numbers? The rational numbers are nothing but the numbers that can be written in the form P by Q, where P is in the numerator, Q is in the denominator, means it is in the form of a fraction in simple words. But we have to remember that the numerator and the denominator, that is P by Q, representation of the number, should have both P and Q integers and Q is not equal to 0. So rational numbers are those numbers that can be written in the form P upon Q, where P and Q are integers and Q is not equal to 0. So let us write that. What are the rational numbers? So let me write it here. All the numbers in the form P by Q. The numbers in the form P upon Q, where P and Q are integers. Means what? They can be negative, they can be positive. One of them is positive, the other can be negative. But Q should not be 0 and Q is not equal to 0. Now why do we say Q not equal to 0? Because when Q is 0, Q comes in the denominator and we divide numerator by the denominator when we want to convert the fraction into some other form, and so division by 0 is not possible. Also, another simple explanation is you have learned fractions, and when you have learned fractions, you have learned that we divide the given object into number of parts. The total number of parts that are formed we write in the denominator, and the number of parts that we use we write in the numerator. Generally, very basic concept of fraction. So if Q is 0, that means the object is divided into 0 parts. So if the object is divided into 0 parts, means it is not divided at all. How can we choose any part out of that? And so that can be the simple explanation that you can remember for Q not equal to 0. Okay. So all the numbers in the form P by Q, where P and Q are integers but Q not equal to 0, the group of all such numbers will be called as rational numbers. Okay. So these are all rational numbers. So now the examples of rational numbers, let us deal with. All integers are rational numbers. How? Let us choose a integer. So we know that 11 is an integer. I am saying that it is a rational number. So if we say that a particular number is a rational number, we must be able to put it in the form P by Q. And P and Q should be integers and Q not equal to 0. How can I write 11 in the form P by Q? I can write 11 in the form P by Q as 11 upon 1. So 11 is a integer, 1 is also an integer. Obviously 1 is non-zero integer and therefore 11 can be written in the form 11 upon 1, that is P by Q, and hence 11 is a rational number. This is true for all integers, whether they are negative or positive or even 0. 0 can be written as 0 is equal to 0 upon any other integer. You may write 0 upon 5, or you may write it is equal to 0 upon 17. You may write it equal to 0 upon any number, 125, anything. So it is in the form p by q. P is an integer because 0 is an integer, 5 is an integer, and denominator is non-zero. Note that in all these expressions for 0, the denominator is non-zero. Our condition is q not equal to 0, where the expression is in the form p by q. Understood? So q not equal to 0. 5 is non-zero, 17 is non-zero, 125 is non-zero. Numerator can be 0, but denominator should not be 0. And therefore, 0 is also a rational number. So all negative integers, all positive integers along with 0, all are rational numbers. Let us consider one example for negative numbers. So if it is minus 19, then I can write minus 19 as minus 19 upon 1. All integers can be written with 1 as the denominator. Okay. Of course, you can write minus 19 as minus 38 upon 2 also. Or you may write it as minus 57 upon 3. In some other way also you can write, but the easiest way is writing an integer in the form of a rational number is writing it with 1 as the denominator. Right? You may write minus 19 or any other number as, this can be written as minus 38 upon 2. Still it is minus 19 because we know the fraction, we always write it in the reduced form. And these are all equal. Right? So all integers are rational numbers. Then which numbers are there that are rational but they are not integers? Do we have numbers which can be written in the form p by q? So they are all rational numbers, right? But they are not exactly in the form of integer. So all integers are rational numbers, but all rational numbers may not be integers. Let us consider an example. So if I consider the number 1 upon 2, or if I consider the number 2 upon 3. So these two numbers are in the form p by q, both satisfying the condition p and q are integers. P is 1, q is 2, both are integers. Q not equal to 0, 2 is not equal to 0. 2 by 3 again is a rational number because it is in the form p by q. But obviously we know that 1 upon 2, or we simply call it as half, is not an integer. 2 by 3, it is not an integer. So there are numbers which are rational numbers but they are not integers. We are going to find whether we can represent them on a number line. We are going to learn different operations on these numbers, that is rational numbers. So we are going to learn rational numbers in details. So first of all, 1 upon 2, 2 upon 3, even you may consider you are familiar with this number, 22 upon 7, right? These numbers, they are rational numbers. They are in the form p by q. They are not integers, right? So we are going to learn something more about these numbers. So let us see what is 1 upon 2, what is 2 upon 3, what is 22 upon 7. Since these are the fractions, we are going to convert them into decimal fractions. And we will see what are the different forms of the decimal fractions of the given rational numbers. So rational numbers, let us by actual division find out the decimal representation or decimal form of the rational numbers, right? So what we have learned up till now, that will quickly revise. We have learned natural numbers 1, 2, 3, 4 and so on. We have learned whole numbers 0, 1, 2, 3, 4. integers minus infinity to plus infinity, and rational numbers that can be written in the form p by q, where p and q are integers and q is not equal to 0, right. The rational numbers, they can be represented or they can have decimal representation. The decimal representation of the rational numbers we are going to find out by actual division method in the next session.